Hi peers, how are you doing? Okay, so we just had class on Wednesday, and I think it was the 12th today. Let me check. Wednesday, April the 12th, yeah. And a couple of you were missing, and so I thought I'd do you up a quick video so that you didn't have to watch the CEMC videos on the method of substitution. I think it was the consensus that the CEMC videos didn't do a really straightforward job on this, and so I went over it with the kids in class, and they seemed to like the direct examples better. So, and that kind of makes sense, so we're going to take a look at some. So method of substitution. We're going to take a look at taking the integral of 2x root x squared plus 1 dx. Now, you can look at your table of integration tables, and you're not going to find one for this one. So we're going to have to do some work on it. I'm going to show you what I'm going to do. I'm going to let u represent this part in here. Now, this takes a little bit of getting used to until you figure out which you want to make your variable, but right now, just trust me, I'm going to make it 2x squared plus 1. Now, if I was to take the derivative of u in terms of x, notice that I would get 2x. Now, thinking about this, I can change this around a little bit, and I can make this either du equals 2x, and I'm abusing notation a little bit here, but what I've basically done is provided that as a fraction and bringing the dx up, so it's 2x dx. The other way I could think about it is rearranging this whole thing. It could be dx equals du over 2x. And again, sort of abusing notation, but certainly a way that we're going to look at for these types of questions. So now, looking at what I've got here, here's the plan. I've got u equals this. So this is going to get replaced by a u. And what I've got here is a 2x times a dx. A 2x times a dx. So these two put together is my du. The other thing I could do is replace this dx by du over 2x, and what you'll know is the 2x on top and the 2x on the bottom will end up reducing each other. So there's two ways of thinking about that. So these two are going to go in for my du, and this part is going to be my u, and what I'm going to get is the integral of root u du. So I've done a substitution which created a much easier integral to do. What I do now is I just do this as I normally would. So this is simply the integral of u to the 1/2 du. And we know that that's going to be, you add 1 to the top. So it's u 3 over 2, all divided by 3 over 2. So it's going to invert and multiply. So it's 2 over 3 plus c. Now all we have to do is go back and do a change of variable again. So if I want it back in terms of x, we'll make it 2, and we'll make it x squared plus 1 to the 3 over 2, all over 3, plus c. And of course, we could play around with that and use change it to a square root sign or what have you, but you know what? That makes good sense to me, and that's where I would leave it. And that is the answer. So if you want to check it, what you do is you take the derivative of this. So the derivative of 2 x squared plus 1 to the 3 over 2 all over 3, oops, kind of goofed that, all over 3 dx plus the derivative of a constant by dx. So this is going to be 0. This derivative, the 3 over 2 comes down, so the 3 and the 3 reduce, the 2 and the 2 reduce. It's going to be x squared plus 1, take 1 away from the top, so it's 1/2, plus, not plus, times the derivative of the inside, which is 2x, which is simply 2x square root x squared plus 1, which again is what we started with. That was the integrand. So it works. Yay! Okay, let's do another one. Here's another example. So let's take the integral of 3x squared over x cubed minus 2 all square rooted in terms of dx. Just going to focus in a little bit. So what I'm going to do is I'm going to let u represent this ugly thing. Why? Because I know that if it represents that ugly thing, then the derivative of u in terms of x, I can see is going to be 3x squared. It's matching up with what's up here. So this is going to allow me to replace the 3x squared and the dx with a du. 3x squared dx. So these two put together is going to be replaced with a du. And this part is going to be replaced with a u. So it becomes integral of 1 over square root u du, which is a much easier question. Remember, it's the same as this integral. So we're going to add 1 to it. So it's going to be equal to u 1/2 divided by 1 over 2, which is going to be inverse. So 2 over 1 plus c. So replacing it back into terms of x if we want, it would be 2 x3 minus 2 to the 1/2 plus c, which is 2 square root x3 minus 2 plus c. Let's see if that works. Let's take the derivative of this. This is the easy form to take the derivative. The 1/2 will come down, cancels out with this 2, leaving me with x to the 3 minus 2 to the negative 1/2 times 3x squared. And notice, that's what we had. So it works. Yay! Let's take a look at another example. We're having so much fun. Number 3, the integral of e to the 7x dx. We've done questions like this before without using integration by parts, by sort of thinking about it, or without substitution. Integration by parts is another method of taking the integral. We're going to look at that later on. But this is a method of substitution. So you're going to let u equal 7x. Therefore, du by dx is going to equal to 7. Now, I'm going to rearrange this. This is du equals 7 dx. Or another way to think about it is dx equals du divided by 7. So what I'm going to do now is I'm going to take this 7x and I'm going to replace it by u. And I'm going to take this dx and I'm going to replace it with du over 7. Integral e to the u, and it's going to be du over 7. Well, that's the same as saying 1 over 7 e to the u du. That's a constant. I'm going to take it out. E to the u du. That's going to equal 1/7. The antiderivative of e to the u is e to the u plus c. Replacing it back in terms of x will be 1 over 7 e to the 7x plus c, or simply e to the 7x over 7 plus c. Let's see if it works. If it does, then this derivative should take me back to e to the 7x. Taking this derivative of e to the 7x is e to the 7x times 7. The 7 on top, the 7 on bottom reduce. I'm back to where I started. It works. Yay! Number 4. Okay, number 4 is the integral of 3x over cos squared bracket 5x squared plus 2 dx. Okay. I'm going to think about this for a minute. I wonder what I'd let u be. I don't know how to deal with this, so I think what I'm going to do is I'm going to let u equals 5x squared plus 2, which means that du by dx is going to be 10x. So replacing what I've got, it's going to be 3x over cos squared u. And this one, I'm going to rearrange it. So it's dx equals du over 10x, which means that the dx will be du over 10x. The x's will reduce out, leaving me with the integral of 3 over 10, that's a constant, times 1 over cos squared u du. Take the constant out, 3 over 10, integral, 1 over cos squared u du. This I recognize. This is secant squared x. In other words, it is the antiderivative of this is tan. So this is going to equal 3 over 10 tan u plus c. Put it back in terms of x. It'll be 3 over 10 tan 5x squared plus 2 plus c. Taking the derivative of this would be 1 over cos squared 5x squared plus 2 times 10x. So what we'd end up with is the 10x on top would reduce with this 10 on the bottom, leaving you with 3x over cos squared of 5x squared plus 2, which is what we started with. Yay! It works. So now we're going to talk about definite integrals. Now a definite integral have numbers. They have an upper bound and a lower bound. So here is a definite integrand that they would like us to do. So what this means is, though, if we were to work this out, this is going to be the antiderivative from x equals 0 and x equals 1. That's what this means, from x equals 0 and x equals 1 in terms of x. So if I'm going to do a substitution and change it in terms of u, if I'm going to do that, then this integration has to be from u equals something and u equals something. So we need to find out these u values, and these u values will be in terms of x. So it's going to be the u value when x equals 0 and the u value when x equals 1. So let me show you how this is going to work. We're going to start off with let u equals x squared plus 1. Therefore, du by dx is going to equal to 2x. Therefore, du equals 2x dx. So I'm going to replace this with u, and I'm going to replace this and this with du. So we get the integration of square root u du. Now, what goes over here? I need upper and lower bounds. So when x equals 0, u equals, using this, u equals 0 squared plus 1, which is 1. So instead of being a 0, when x equals 0, u equals 1. And the other one is when x equals 1, u equals 1 squared plus 1, which is 2. So it's going to be when u equals 2, because when x equals 1, you put in 1 here, square it, you get 1. This will be 2. So this is going to equal, so the antiderivative of root u is going to be u to the 3 over 2, 2 over 3. I don't need plus c anymore, between 1 and 2, which is going to equal 2 over 3, 1, 3 over 2, subtract 2 over 3, 2, 3 over 2. Other way around, 2 minus 1. So it's from this one, subtract that one. So this is going to be 2 to the 8 square rooted. And this is going to be 2 over 3. This is going to be 4 times 2, so 2 root 2, so it's going to be 4 root 2. And so your final answer is just going to be left like this. I guess we could leave it, or we could leave it like this. And actually on the AP exam, we're going to find that we can leave it like this. Okay? But that's a nice way to clean it up. Let's do another definite integral. This definite integral is going to go between pi by 6 and pi by 2. And it's going to be cos x, sin x, dx. So I'm going to let u equal sin x. By doing that, du by dx is going to equal cos x. So du is going to be cos x dx. So once again, this is going to be replaced with a u. This cos x dx is going to be replaced with du. So we're going to get u du, I got to change these. These have to be in terms of u. When x equals pi by 6, u equals sine of pi by 6, which is equal to 1/2. And when u equals pi by, not u, when x equals pi by 2, u equals sine of pi by 2, which is going to be 1. So the upper limit in terms of u is 1. The lower limit in terms of u is 1/2. When we take that integrand, it's going to be u squared over 2 between 1/2 and 1. So that's going to be 1 squared over 2 minus 1/2 squared over 2. So that's going to be 1 over 2. That's 1 over 4, 1 over 8. So that's going to be 4 over 8. So it's going to be a final answer of 3 over 8. Okay, guys, I have one more example, but I'll come back with that one on my last video.